This question is a good example of, no matter how many kind of practice questions you do, past papers or otherwise, like there's always questions out there that are a little bit different and that you've never have seen before. And quite often that's going to be the case for these final questions in papers. This is the last pure paper, sorry, the last pure question in this paper. The other thing I would say in this question is that it's very easy to dive straight on into some algebra rather than take a step back and think about it. This is something I'm guilty of. So if you read this question and understand it, actually the first thing you can spot is that because the first term for A is equal to the last term for B, and then the first term for B is equal to the last term for A, then they're basically the same sequence, but same progression, but just in an opposite order. So for B, the difference, well, for A, the common difference is D. For B, the common difference is going to be minus D. Okay, and if you kind of take a bit of time to think about that, you can get there straight away. Now, I didn't, and I'm going to show you like, okay, if you don't realize that, you can still work that out, which is what I'm going to do now. So let's look at A. The first term is 4, and the difference is D. D equals D. That's a little bit confusing, isn't it? So I'm going to maybe use capital D for the difference here. And then I can write down the nth term. In fact, it's going to be A. Maybe I'll write it as AN in this case. It's going to be 4 plus n minus 1D. And let's take a look at B. We know that, well, B1 is equal to A100. So actually, let's work out what A100 is. It's going to be 4 plus 99D. So for B, I've got B1 is equal to this, 4 plus 99D. And then I've got B100 is equal to 4. So I could write down that Bn is equal to 4 plus 99D as my first term, plus n minus 1 times some different difference. That's it. I don't know what that is. So I'll call it dB. But then I know when I put in 100 that I'm going to get 4. So 4 is equal to 4 plus 99D plus 99, because I'm just, remember, I'm just finding out the 100th term of B now, but I know it's equal to 4. So I've replaced n by 100 and Bn by 4. I'm going to get 99dB. Okay, the 4's cancel. I can divide through by 99, and I will get that dB is equal to minus D. So there's a little proof algebraically. But you can see it's a lot more steps than just kind of looking at it for a little while and realizing it's got to be that way. But where that leaves us then is I've got my n. I'm just going to put a little box around it, and then for Bn, I've got 4 plus 99D, and then it's going to be well, let's write it as minus n minus 1d. So we're now told that there's at least one value of I for which bi equals 10 plus ai. So let's sub in I and into this equation. So this is it. Well, this all that was groundwork. Really, this is part A. Well, it's continued really. So 4 plus 99d minus I minus 1d is going to equal 10 plus 4 plus I minus 1d. I've just subbed I into both of these and then use the equation here. The 4's are going to cancel again. I'm going to expand this out. 99d minus id plus d, because it's a double negative, is going to equal 10 plus id minus minus d, sorry. Then I want to work out I, basically. So I'm going to get, it's going to become 2id. I'm going to add it onto that side. I'm going to minus 10 and add d. So I'll get 2id is 100d. Maybe I'm doing this too quickly. Okay, I'm just going to, let me, let me combine these together. So I'll get 101d minus id equals 10 plus id. And therefore 2id, if I add on the id to both sides, is going to equal 101d minus 10. Now I can divide through by 2d, which will give me I equals 101 over 2. So these will cancel out. Minus 10 over 2d, which will simplify to 5 over d. We've got the required equation. Then we're asked to hence show that it's impossible for this equation to hold unless d takes certain values which should be stated. So remember, I has to be an integer. It's like a term number, and d is also an integer. Now, if you say put d equals 1 in, then you'd get 101 over 2, which isn't a whole number, minus 5. So we somehow, and let me rewrite it actually, I is going to be 50, which is a whole number, because that's 100 over 2, plus a half, minus 5 over d. So I need the minus 5 over d to like cancel out with the half, or at least cancel out the fractional part. You might do this question, and I think the mark scheme does, just by like thinking about some values. D equals to 2, for example, would give us 5 over 2, and that would work. You might try, no, 3 isn't going to work, 4 isn't. Okay, we need to get another kind of multiple of a half, but it's actually an odd multiple of a half, not like, 2 over 2, because that would be a whole number. But as you go on up, you might also see that 10 works, 5 over 10. But after you've gone past 10, you're never going to get a half again, So actually those two are the only answers. Now I didn't do it, I like did it a bit more rigorously, I think. So this is how I did it. I said that, so this is my alternative approach. I require half minus 5d to be an integer. And therefore, I multiplied it by 2. Therefore, 1 minus 10 over d must be an even integer, because I've times it by 2 to get rid of that half. And I'm honing in here, because therefore 10 over d must be odd. So I've got an odd minus something gives me an even. But d is it's a positive integer, so we can just cycle through the factors of 10. If d was equal to 1, we'd get an even integer. But if d was equal to 2, we'd get 5, which is an odd integer. It'd be okay. D is equal to 5, we get 2. Nope, that doesn't work. But if d is equal to 10, we get 1. So that is a slightly different approach, maybe going into more detail than is needed. But I feel like this shows with absolute certainty that there are no other answers. Anyway, there we go. Well done on this question.